Hi guys, so we're gonna head through the Newton's First Law Station Lab for those of you who are virtual and or absent. So starting with Station 1, the materials are a bottle and a piece of paper. So what this station is gonna kind of look like. We have a piece of paper underneath the bottle. We're gonna pull the piece of paper from underneath the bottle. You're going to predict, so underneath Station 1, Question 2, predict what's going to happen when you pull the paper from underneath the bottle. So pause the video and predict. When I pull this paper, what's going to happen to the bottle? Unpause when you're ready to go. Okay, so let's try and get a good angle here. Okay, so I have this bottle on top of the piece of paper. I'm going to apply a force to the piece of paper, and let's see what happens. Okay, so the bottle stays in place. We apply a force to the piece of paper. That one's better. The best one. All right, so under 3, you're going to explain what you saw, what you describe what you saw. For number 4, you're going to explain how does this demonstrate Newton's first law. So how does the bottle staying at rest, how does that demonstrate Newton's first law? Okay, station number 2. So in station 2, we have our materials, our car, a penny, and a ramp. Okay, so basically what we're going to do here, we have a dynamics track, we have a dynamics car, and we have a penny. And this penny is going to act as a person inside of the vehicle. Our goal is to figure out, as we increase the height of the ramp, what happens to the penny, the distance that the penny moves when it leaves the car. Okay, so underneath our ramp, we're going to start out with just one textbook. So we're going to start off with the height of one textbook. At the top of the ramp, we're going to have our cart and the penny as a passenger. Okay, when you release the cart, it's going to hit the bumper at the end of the ramp. Okay, but the penny is going to keep moving. What we're going to do in this station is measure how far does the penny move from the front of the car as the height of the textbooks increase. So for our first height textbook of one height, we can see that from the end of our car to our penny is 31 centimeters. 31 centimeters. It flies 31 centimeters from the end of the car when it begins with one textbook underneath the ramp. So distance there is 31 centimeters. Now we're going to increase the height of the ramp. So I'm going to add a second textbook underneath the ramp, and we're going to measure how far from the front of the car the penny is going to land. What do you think is going to happen? So as we increase the height of the ramp, what do you think is going to happen to the distance that the penny moves? All right, now we're going to give it a shot. So we're going to figure out where the penny first hits the table. That didn't work so well. I'm going to try it again. Still about the same. All right, so at 2 textbooks, our penny landed 32 centimeters from the base of our car. So 1 more centimeter. Okay, so our delta x is increasing. Let's try a 3rd textbook and see if we get that same pattern. Okay, so as you can see here, we now have 3 textbooks underneath the ramp. Let's see what happens to the penny. The car hits the bumper. All right, so I'm gonna put them back on the car. And let's see what happens. Oh. All right, so you'll see that the penny actually landed in the sink. We're going to estimate where about it first bounced. So you guys probably have a better idea because you could see it via video. I'm going to need to do it one more time to see exactly where it lands. Okay, we want where it lands on the first bounce. All right, I'm going to say it's about here. Hopefully we agree. Okay, that's going to be about 35 centimeters. About 35 centimeters. Okay, so as the number of books increases, the distance that the penny is thrown also increases, which means that if you're a person, right, your distance you're being thrown from the car also increases. So if you think about it, right, number of books increases how far away you're thrown from the car. What would number of books, what would that translate to in terms of a car? So the higher the ramp, what's happening to the car as it hits the bumper? Okay, so the higher the ramp, the faster the object's moving when it hits the bumper. So the larger the speed of the object initially, the further away from the car it's thrown. So if you're traveling 60 miles per hour and you're not wearing a seatbelt, you're going to be thrown further from the front of your car than you would be if you were traveling 25 miles per hour. Okay, so the number of books is related to the speed of the penny when it leaves the car. The faster the speed that I was originally traveling, the further from the car it's going to be thrown. All right, so that is station 2. So go ahead, fill out the rest of station 2, and then we'll head to station 3. Okay, so for station number 3, we have our materials, our index card. We have a beaker. We have a little piece of tissue paper in there. And then we also have a euro. Okay, so for this one, the directions say you're going to take the beaker. On top of the beaker, we're going to lay the index card flat. In the center of the index card, we're going to place the euro. And we're going to flick. So we're going to apply a force to the index card. Our goal is to take a look at what happens to that euro. Okay, so I'm going to apply a force. I'm going to flick the index card forward, and let's see what happens. Oh, I messed up. Let's try it again. Sometimes I get nervous and I'm going to flick the actual beaker and hurt my hand. So I kind of messed up that flick. Try that one more time. All right, so I'm going to apply a force. There we go. Okay, so you'll see, right, you're applying a force to the note card. The note card is going to move forward because of the force you're applying to it. Make sure it's centered. Okay, when you flick that note card, the coin is going to fall straight down into the beaker. So you apply the force to the note card, so the note card's going to move. The coin is going to fall straight down. Okay, and it's asking why. Why does the coin fall straight down? What force is acting on it? Alright, that is station 3. For station 4 and station 5, you can see on your lab sheet that there is a tiny URL link that you're going to follow. So the first tiny URL link is /Newton1 NFL1. You're going to watch that 3-minute video and answer the questions based off of the video. Station 5 is a GIF. So you're going to access that GIF using the link on the lab sheet. From the GIF, the animation, you're going to describe what happens to the man in the car and how does that follow Newton's first law. Okay, email me with any questions.